Okay, so we have to take the second derivative test to find the x coordinates of the relative extrema of the function f of x equals ln of x plus sine x from 0 to 2 pi. Now notice this is a calculator question, so definitely paper 2. Get your calculator ready. You should be opening up a graph similar to what you see with mine. Now, they gave us restrictions. They said x is from 0 to 2 pi, so you should be fixing your window right now. Go to window settings. Your x min should be 0. And 2 pi, you can put the numbers 3.14 times 2, so let's just make it 6.3. You could also just put in 2 pi here as well. So for now, let's just do that and hit OK. And now we have a better window of what our graph's going to look like. Okay, so let's go ahead and take the first derivative of this function. F derivative of x ln x is 1 over x plus cosine of x. Now, we have to find the zeros of this function, but in this case, it's best to use the graph to identify where the zeros are. So let's go ahead and move over to the graphing utility, and let's go ahead and type it in. Let's make a function. Oh, let's not get that going. Now I already typed it in here, so go ahead and just press enter. There we go. So that's what it looks like. Now my first extrema is where the graph crosses the x-axis. So let's go ahead and find the 0. Let's go to analyze graph, 0. Now lower bound, it's kind of guessing. Well, let's find this one right here. Lower bound, check. Upper bound, check. Oh, there's my 0, 4.49. Now we have to do that again. Analyze graph, 0. Let's go. So there's the other one. So I have my two zeros, 2.07 and 4.49. So again, the 2.07 and the 4.49, that's the value of the extrema. All right, so let's go ahead and write our x values down. So x equals 2.07 or x equals 4.49. All right, now all we need to do is use a second derivative test to identify if this is a minimum, if the extrema are minimums or maximums. So let's go ahead and do that. F derivative, double derivative of x, 1 over x. It turns out to be, I'm going to do it quickly, negative 1 over x squared plus minus sine of x. That's our second derivative. And now what do we need to do? Just test if f double derivative of 2.07, is it positive or negative? And the same thing, f double derivative of 4.49, is it positive or negative? Okay, best thing to do is just plug these values back into the calculator. Okay, so I did the calculations, and as you can see, both results, when I plug in the extrema into the second derivative, I get the results of they're both negative. So all that means then is 2.07 and 4.49 are relative. So concave down, it's an extreme value, so it looks something like this, right, for both points. So that means they're both relative maximums. Okay, and that's part A. Okay, here we go again. Find the global extrema, so the absolute max, the absolute min of f of x equals x plus sine squared x from 0 to 2 pi. Let's go ahead and get a graph ready, making the window from 0 to 2 pi. So I have my graph, menu, window settings, so forth. X min, 0, and I believe, I'm sorry, not 0 to 2 pi, but just from 0 to pi, so 3.14. Let's make it a little bit bigger. 3.15, and bam, that's it. So now we got our graph. Okay, let's go ahead and take our derivative. I made a quick mistake. I wrote sine squared x, but it's actually sine x squared. So I fixed that now. Let's go ahead and take the derivative. Let's do it. So here we go. Change colors. F derivative of x equals derivative of x is 1 plus derivative of sine is cosine. Rewrite the x squared and now take the derivative of the inside, which is 2x. So our result is 1 plus 2x cosine of x squared. Now let's go ahead and get the graph up for this function, set it equal to 0, and let's find our zeros using the graphing calculator. Okay, I typed my graph, I've typed my function into f1 of x, and now notice I have 3 zeros. That's why using the graphing calculator is important. So let's go ahead and analyze the graph. Let's find all our zeros. It asks for a lower bound, so let's choose a lower bound here, and let's choose the upper bound right there. There's my first 0. Let's do this 3 more times. I'm just going to go ahead and skip to the end, just doing it over and over again. Okay, I did the process 3 times, and I got my 3 zeros. Now we're going to go back to the calculations again, to the function. Okay, so we have our x values when the extrema is equal to 0. What we need to find now is we go to the original function and we basically find the y value there. So we got to find f of 1.39, f of 2.12, and f of 1.83. And yeah, so we have to do f 1.39, which is 1.39 plus sine of 1.39 squared to find the y value. We do this. Okay, so we found the positions of all the extrema. There's one more, there's 2 more points we need to find. We need to find f of 0 and f of pi. Then we can determine absolute minimum or absolute max. So we just got to do f of 0, which turns out to be 0 plus sine 0 squared, which is simply 0 plus 0, which is 0, and then f of pi. F of pi turns out to be 3.14 plus sine pi squared. Sine pi squared, interesting. Use a calculator to figure that out, and what do we get? So 2.71. 129, round to 3 significant digits, so 2.71. Okay, and now make your claims. Which one's the maximum, which one's the min? So looks like my lowest y value is 0. So I have f of 0, which equals 0. This is my minimum, my absolute minimum. And then what's my highest point? F of 1.83, which is topping out at 3.82. So there is my max. There we go. All right. Gosh, 8 minutes and 30 seconds almost. All right, guys. That's the nature of these types of problems. Anyways, that's the conclusion. Moving on.